Okay, let's start with explore number 2 of nuclear forces. And just to remind ourselves, this is related to our discovery education, physics 2.2.2, right? All right, so the essential question we have written up at the top, it's simply what you see here on the left in green. How are nuclear fission and nuclear fusion related in terms of mass and energy? So think about what you know. We've talked about nuclear fission. We've talked a little bit about nuclear fusion. Other teachers you've had in the past perhaps have communicated this as well. What are you thinking right now? Go ahead and write that down as what I know or think. Okay. And remember, just do your best. Not looking for some perfect answer this first round. Okay, hopefully you hit pause and you answered this question, what I know. So let's go ahead and start our notes. And it starts off with these ideas of fusion and fission. In very simple terms, we could say, if we were to describe these words, we could say that fusion is when you take two items and you fuse them together into one item, right? And we could say that fission, on the other hand, would be to, if you were to take something and you were to split it apart, then you'd have two smaller parts. Okay. Fission is, we could say, to break apart, to break apart, right? And fusion is is to bring together. Okay. These are just some simple ways to connect this for you. Let's actually take a look at the definitions. Okay, we can click on that, and there's a good video animation. The reaction where two or more nuclei of atoms combine to form a single nucleus. All right, so let's actually write that down. Okay, a reaction. Okay, so a fusion is a reaction where two or more nuclei where two or more nuclei of atoms combine to form a single nucleus. Okay. And if we were to get out of here, I'll just close it down and now click on the term nuclear fission. Again, remember, you guys have the animations. They give you descriptions in the details. They give you context, which is really important. But we're just going to focus right now on the definition. A reaction where the nucleus of an atom splits. A reaction versus fission. And fission is with two S's. A reaction where the nucleus of an atom splits. Is a reaction where the nucleus of an atom splits. Okay, all right. Taking a look here, the next sentence, a fusion reaction joins lighter atoms to form heavier atoms. Okay, so with fusion, a reaction where two or more nuclei of atoms combine to form a single nucleus. So in fusion, we're just going to make a connection over here. Fusion joins lighter atoms to form heavier atoms. Okay. And this type of reaction results in the loss of mass, which is converted into energy. Okay. Some mass is lost, resulting in a release of energy. Not just a little bit of energy, but a lot of energy. Okay. Physicists have been able to sustain fusion reactions in labs because of the extreme temperatures required. That's kind of an interesting point. When you think about a star, because that's where we see nuclear fusion, how does a star maintain fusion? Well, there's an immense amount of gravity, which is keeping the star very hot. And we have a hard time on Earth being able to generate that much power to sustain nuclear fusion. Okay, but we could. Where could we write this down? Let's put down letter C. I'll just put a little star here. Okay. Fusion is hard to maintain. It's hard to keep it going because it requires extreme temperatures. Okay, so it's a hard thing for us to do. Okay, now as we move down here, let's talk about fission. Okay, a fission reaction splits apart atoms of heavier elements, forming smaller atoms. A reaction where the nucleus of an atom. So let's go and put this on the nucleus of an atom. What kind of atom? An atom, a heavy element. Okay, a large one splits. And what does it do? It splits into smaller atoms, aka elements. We want to make a note to ourselves. Fission also results in a final atom that has lost mass resulting in a release of energy. Again, lots of energy. Okay, so that's kind of a common theme in both fusion and fission. You start off with more mass, you end up with less mass, and the process has released a lot of energy. Make sure you watch the videos, okay? Okay. The second thing that is discussed here is Einstein and his theory of relativity. Roman numeral 2, the theory of relativity. And we can thank Einstein for this. Um, Developed by Einstein. Basically, he said that everything is relative. Everything is relative. Sounds too simple. It is too simple. Except the speed of light. In a vacuum. Okay. So some of the things that he came up with here was he realized that there's a fourth dimension. There is a fourth dimension. Not only do you have the typical three dimensions, okay, you have your X, right? You have your Y, and you have a Z axis. And with this three axis system, you can describe the location of anything relative to something else. Okay, but time is the fourth dimension. Along with X, Y, and Z, there is time. Time. That's your fourth dimension. Okay, time. Okay. He, in his theory of relativity, said that as the only thing that can travel at the speed of light is light itself. We, as humans, will never be able to travel at the speed of light. The only thing that can travel at the speed of light is light. Because as you approach light speed, comma, mass increases to infinity. And so does the energy required to move it. if you had a spaceship, and you start to get faster and faster towards the speed of light, the mass of your spaceship would just increase to infinity. And if you have something that massive, you're going to require an infinite amount of energy to move it, which just can't happen. Okay. He also said that time also stops as you approach the speed of light. Also, time slows down, ultimately stops as you approach light speed. He also suggested that the um, the idea of a space-time continuum, space-time continuum. He talked about how planets are not actually orbiting, say, the sun. They're actually following in straight lines that are distorted by the space-time continuum due to mass distorting that. So he's had some pretty interesting ideas out there for sure. Okay, what else did Einstein also gave us? Um, Einstein also gave us the mass energy conversion formula. And this formula related energy to mass. Energy was directly related to mass times the speed of light squared. Remember that the speed of light is 186,282 miles per second. It's like a massively large number. So you only need to multiply, and if you square that, that's even bigger. Multiply that times even a tiny bit of mass, and you're going to get a lot of energy because light is such a big number. Okay, so this was basically that the two ideas, energy and mass, are related. Okay, and we'll say this was energy, mass, and then C, light. Okay, C equals the speed of light. All right. Well, so what I encourage you to do is also watch this video, Einstein and the Theory of Relativity. We'll talk a little bit more about this in class, but that concludes our notes. So let's just go ahead and drop our lines all the way down. And let's go ahead and write our summary. Okay. Summary paragraph. All right, we'll talk to you soon, all right?